So, hello, everybody. It is day 12 of studying maths in every day. And today is Friday. It is just a weekend. I don't do anything on the weekends, basically, right? But I have to keep the streak on and I don't want to miss a day. So, I decided to review like some old stuff that I have learned on the Friday. So, I will be reviewing like the old lessons, you know. So yeah, it will be a hobby, will be another beautiful day, and all I will do is just a session. Okay, all I will do will be session. So I will be studying only 15 minutes. So yeah, the course that I'm taking got a notes which is called just like algebra 2 notes. So I will be reading these slides. They contain like 400 pages. Oh my gosh, I wasn't expecting this, to be honest. Is this the full book or like is it the notes? Oh my gosh. Wait up. Notes. Dude. Yeah, so it is different. There is two different stuffs. It is the formula sheet and also notes. So notes will be the whole book, right? So yeah. So should I try this one? Like the only formulas? Maybe. And then I will be watching one of these lessons, and I would like to watch basically this one. Right up. One that he was talking about problem solving to the point he made. Okay, an approach to problem solving.
Okay.
So yeah, I will be like, I'm gonna start the timer. It is day 12. Oh my gosh. It is amazing. It's literally amazing, man. It's literally amazing. It is literally amazing. Okay. Oh, I'm gonna get confused with all of the stuff. Right up. Let me close one of these. Maybe that one. Or is this one too? Okay. This one too. So this one in here. So this one's just the same. So I'm gonna play this one. Okay. You know this topic, like an non-zero real number raised to the power of 0 is equal to 1. This is like so interesting. I watched a guy which is called, I have to pull up on YouTube. I watched a lecture that's talking about how it is possible to get like number raised to the power of 0 is equal to 1. How is it possible? So I watched a lesson and it is so damn good. Like, you know, if you go all the way down, coming from like 0.09 all the way to 0, it's kind of like it is approaching to 1, but like it won't go all the way 1. So I'm gonna pull up no, it's not watch letter. Oh my gosh, could be somewhere right here. Where is it? That's maybe okay, an approach. Yes, okay. So dividing by 0, no. Okay, hook. Oh my gosh, I thought like it was in here. It is not. Okay, just forget it, man. You know, get it, I guess. So yeah, negative exponents. Yeah. You're always gonna like put it. Okay, if you get like a minus exponent, then that means it is just like that position is not its position. Like if there is a number with a negative exponent in the denominator, then that means it is saying I'm not belong to here, so you have to move me to the numerator. And after that, like it will be a positive. So it's just like that. So this one, it got a 1 in the denominator. So yeah, it just like went all the way up. It was in the numerator and it ended up in the denominator, and that's how we ended up the positive exponent. This one is just the same too. It was just like this, a b. So if it goes to the denominator, that means it will have minus. So negative exponent is unproductive rule. Negative exponents unproductive rule. So just like, yeah. Okay, so you believe it. It's just like that is reciprocal. Both they will get minus, right? Both they will get minus, but like A went to the denominator and B went up on the denominator. So on the numerator, I mean. So that's how they ended up both positive. So fraction exponents. Fraction exponents. So what like is the denominator, or like is this one the indices, b is the indices, and a is the power to the radicand, right? Yeah, and b is the indices. That's how it is. So it's just like that means it's x power 1 and the integers is just 2. So that means we don't write 2. If it is 2, that means it's just like square root. So we don't write the 2, like we don't write it explicitly. If you see like any square root without like any indices, that means it got a like positive, it got a 2, like. So yeah, but if it is 3, then you have to write it explicitly. This one is just 2. So yeah, this is so damn good. Okay, so what about something like this? It will be just the same, like nothing will change, right? This is equal to, I guess, a, and then okay, For somehow I didn't get this. What do they mean by this? And this too. Didn't I study this? I don't know. I don't remember anything about this. I guess AB. Maybe lab. What I want to know. So this would be just the same, right? Okay, so this. Okay, it equal this to this. Right. It makes sense then. What about this one? So funny. Yeah, and then this will be AD plus AC. Will it be like this? Will it be like this? Will it be like this? And I guess A B plus C. Oh, nope, you don't need that. So yeah, will it be like this? Like that? Maybe. Okay. Rationalizing the denominator. Oh my gosh, I like this. You're gonna multiply the denominator on both, right? To get rid of the square root in the denominator. So we don't wanna let so we don't wanna have any square roots in the denominator. So to get rid of it, we're gonna multiply like the same on both the numerator and on the denominator. So what I mean is, just to get rid of b, I think you need to multiply b both on the numerator and on the denominator and the numerator. That's what I think, right? Okay, rule is with radicands. AB is equal to AB. Okay, AB this. Okay, so rationalize in the denominator. Okay, A B so you're gonna multiply like the square root in the denominator on both the numerator and the denominator. and you're gonna end up this b and then just b. So just like b squared would be just b when you get rid of the square root. So rationalizing with conjugate method. Rationalizing with conjugate method. Conjugate. Okay, the conjugate of the polynomial is the same terms with the opposite sign in between. Okay, it's the same terms with the opposite sign in between. So this one is just like the same. You also gonna multiply the denominator on both the numerator and the denominator, but like the sign flips. So if it was minus, then that means it's going to be like positive. So that's how it is. Rationalizing the denominator with conjugate method. 3 and also send this. So yeah. So it would be 9 and then wow, do I need this? Get longer and longer. 5 times 5, 25, 5 times 3. And 5, okay. And then where up? Okay, 5 times 5, 25, 5 times 3, negative 5, 3. And then this one is just negative 5, 3. Then why this not minus? I think they just like it is 9, but like they get rid of the square root, and that's how they ended up today. Okay, what do they need to do? Like 25 and then 3. It's just like that, and this one and this one, they will cancel out, right? So yeah, interesting. Okay, ratios and proportions. Ratios and proportions. Ratios and proportions. Okay, ratio, a comparison of two numbers or other mathematical expressions often written as a function. Proportion, an equality between two ratios, right? Ratio, cross multiplication, so you can multiply this and that, and then that's, yeah, okay. Chemical compounds, I didn't study this. Did I don't remember. I don't think so I did. Wait up, let me pull up my notes. But like, I'm sure I didn't study this lesson. Just like skip it. Yes, I didn't. I didn't. So fraction is to decimal is 2%. Fraction is to decimal is 2%. Okay, percent to decimals divided by 100. Like, you know, in this lesson there is something that I remember. You don't even need to multiply by 10. You don't even need to multiply by 100. I mean, what you need is something like this, something which is so simple. So okay, if imagine you have 50%, you got 50%. Basically, you got 50%. All you need to do is to move like 2 digits to the left and put it 0. That's what I think. So this is what you think. This is what you need. You're gonna move 2 digits, and right there you're gonna put a dot, then 0. So 0.50, and you don't need to write the 0. Okay, so 0.5 means like the. So if you wanna, oh my gosh, okay, what I just mean is just if you wanna change percent, convert maybe percent to decimal, all you need is just to move 2 digits to the left, and then that's it. So you already got the decimal version of that percent. So it is also the same. If you wanna convert it back to percent, you're also just gonna do the same. You're gonna move 2 digits to the right, and then you will end up 1, 2, so it will be 5, will be 5. See, like 50%. Basically, if I had 50, dude, it's just like something like this. Wait up. I don't know why, but like looks like that I forget it. But like you're gonna move 2 digits to the right, and you're gonna move 2 digits to the left. That's how it was working basically. So don't know if there is something. So I don't know if there is something that I'm forgetting. Let me pull up the notes. There is like some simple stuff is that you can forget. You don't look back again, or if you don't solve problems that contains like the thing, fractional exponents. Okay, right up. I'm doing some. Let me ask the AI. Not exactly. You cannot just move 2 digits to the, I mean to the left. Oh yeah, like the electricity just went out. So it was out like maybe half a minute, but yeah. They changed some, like I think they switch machines, you know. They use a separate machine for the daytime, and they use a separate machine for the nighttime. I don't know if this is the same like for other countries, but like when they doing this like thing, when they switching between machines, and then that means the electricity will be out for a second. So yeah, so that means you're gonna lose your entire progress, to be honest. That's what it is. Just like you have to, if you are recording something, you have to also you have to also like start recording again. You're gonna lose every thing. So it's not a good thing, to be honest.
Okay.
So yeah, it's not a good thing. So I was asking like this dumbass how to do this without like multiplying by 100. Can I just move the decimal point 2 digits to the right to convert it percent? Yes, exactly. Okay, that's the shortcut. So okay, so move the decimal 2 places, right? If it was right here, then that means you're gonna move it to the two places. So here is 1 and 2. It will go right here. And what I was saying is this, I guess. I was saying this 1 and 2. So it's like, is there any decimal in here? So that means it will be then like 50, 0.50. Right? So well up. So move the decimal 2 places. 1, 2. Well up 1. Okay, it's 2 right. Okay, two places to right. Okay, it's 1, 2. Well up 1, 2. 1, 2. Like I don't even have another number. What the? Okay. Move the decimal to 2 places. 1, 2. So where up? So if I get this, yeah, okay. So 0.4. So it is 1 and 2. So you're gonna fill another 0 in here, right? That's how it will end up this. So what about this 75? 0.75. Okay, you're gonna like move 2 digits to the right to convert it into percentage. So this means it will be 75. Okay, what about if you get 50 then? So you're gonna move this 2 digits to the left. So you will have this right here. It will be 0.50, and then it will also be 0. Okay, makes sense. So okay, what about, important to note, this works because multiplying by 100 shifts the digits 2 places to the right. But be careful, if the decimal has fewer than 2 digits, you might need to add 0. So this is the problem that I was facing, right? This is the thing that made me to question this whole thing. Yes. Okay, so you need to add a 0 and you're gonna start counting from here, not here, right? So it is 1 and 2. So yeah, that oh my gosh, why am I stuttering like okay, it's good information, to be honest. Okay, fraction to percent. Fraction to percent, change the fraction to decimal, then change the decimal to percent. Okay, fraction to percent, change the fraction to decimal. How can I change a fraction to decimals? How can I change fraction into decimal? I literally forget it. I don't know. Okay, to change a fraction to decimal, you simply divide the numerator. Okay, so you simply divide the numerator top by the denominator. So if it was this, you just need to divide it Okay. So like any shortcut though. I need a shortcut. Like, is it possible? How? Notice if the division doesn't need neatly, you will get repeated. Yes, I remember this. I remember this. So like if it is repeated, then if it is just like something like this, 0.3, 3, 3, 3, you're just like gonna make it like this. You're gonna make it 0.3 with like with this little line on the top. So that means 3 repeats, right? So also I think it just came into my mind, when you want to do something like this, you gonna set it up as a long division, right? So it will be something like this. 5 will be the divisor, and 4 will be the dividend. So it will be something like this. So you're just gonna add a 0 into right here. You're gonna put a point on that. Dude, I think oh wow, this is amazing. I swear to God, this wasn't in my mind. I totally forget it. But like, I think this is how it is. I think this is how it is. I still like not sure, but like, yeah. So I'm gonna say, so how can I do it without using a calculator? Is long division is long division a way? I don't know. Exactly, long is a classic way to turn a fraction into decimal without a calculator. Okay, so I was right on this. So 2 will basically be the divisor, and then this will be the dividend. 2 doesn't go into 7, so place a decimal point and add 0. Think of it as 10. Okay, so what up? Numerator and then denominator. So this is the same thing, dude. Yeah. So what you need is just like, it's just like to put so on top, not 2 but 4. Okay, and not even 4, it will be 8, right? It will be 8. 8 times 5 will be 40. That's what I think. This will just 0, but like this will be, so where is it? Yeah, something like this will be, you're gonna change it into decimal at first place, so it became 0.4, and you're gonna change 0.4 into a percent. So you're just gonna say 1, 2, it will be 40%. So let's ask AI. Fraction, nah, just say convert this fraction into percent. It is 4 divided by 5. It should be 40%. No. Oh, it is 8. Yeah, I told you it was 8, right? Oh my gosh, I even said 8. Why I didn't put it 8? It's 80%. So yeah, man. Good. Percent markup. This lesson was so damn good, but it was goated, dude. When I was studying this lesson, it was literally goated. Okay. Percent markup formulas. Where? So it's just like, let me clean all of this. First of all, let me clean all of this. So this whole percent markup thing, it utilizes this method. Is just like this method is percent to decimal, decimal to percent, and also fraction to percent. It all utilizes that. So percent markdown formulas, where percent markdown is the percentage of the original price of the payment of the item. Original price is the price the person or the store was selling the item for before they discounted the discount amount. Yeah. This is so simple. I believe in it. So at the end, you just like gonna if you wanna get the discounted price, then that means you just like gonna subtract the original price from the discount amount. That's what you need to do. It is an amazing lesson and amazing techniques. I think I spent some time with it, and I even wrote some like beautiful notes about these two lessons. So this one is just like percent markdown, and then the other one was percent markup, I believe. Where is it? And the commission too, and also the interest is. So this is not a compound interest. This is a normal interest. So I wanna know how they calculate the compound interest is, like interest basically. So am I right? Basically, I forgot the thing, but is there like compound interest? There's something which is called compound interest. Even we can just like Google it maybe. What is compound interest? So there is two like interests. One is normal interest, I guess, and the other one is just compound interest. I'm not sure basically, but yeah, general formula for compound interest. But it's a tape where you earn interest, not only the where you earn interest, not only the original amount, the principal, but also the interest that has already been added. Yeah. So it is like it is just like an interest that is made up by the principal amount and also the interest that has been added up already. So if you just like if you put like $50 in the bank and you get like $5 in as an interest in the first month, and then the second month they will be calculating your interests from not the $50 but like the $55 that you have in your bank account. So that's what it is. And the normal like interest, I guess, is just like they're gonna give you like the interest that they will give you will be based on the principal like amount that you already, they got a word for this, deposit, I guess. Deposit, I don't know if that's the way to say it. I think my English is not English. Let me check. Deposit. Okay, what is the past of this then? Okay. Past tense. Okay, deposit. How to pronounce it? I don't know. Deposit fair found. Oh my gosh, this is why this is so hard to find? What the heck? Oh yeah, just forget. So this is something that I'm interested in to learn, like this compound interest. So yeah, I think I'm about to review the whole thing on another day maybe. Where is it? Like starting all the way from percent markup to calculating interests. It is amazing, to be honest. Complex fractions, expression with fractions in either numerator or both, divided by a fraction we come with. So yeah, it's just like changing the sign. If it was this, making it like multiplication, and then using the reciprocal. If it was 1 2, then that means you're gonna make it 2 1. So and then you're gonna multiply. This one will be multiplication. Very interesting. So I don't know how many minutes left, but I got 10 minutes left. Can I make this video? If I even watch it, like if I even watch it 1.5.
We're about to start something that a lot of people just dread. You say word problems, people run out of class screaming, I hate word problems. Why? Why would you make me do this? I get it. They're not fun because you put the challenging part about reading and kind of diagnosing what's going on with math, and they become challenging. Fun. Okay, well, we're about to start something that a lot of people just dread. You say word problems, people run out of class screaming, I hate word problems. Why? Why would you make me do this? I get it. They're not fun because you put the challenging part about reading and kind of diagnosing what's going on with math, and they become challenging. Fun-ish, maybe? I don't know. It kind of depends on who you are, whether you think these things are fun or not. Some people love word problems. Most people just don't like word problems because they don't understand how to go about solving them. Once we start understanding how to do them, they become a lot.
So I fall into this lesson basically. I thought he gonna talk about like problem solving in math in general. Like he's talking about like problem solving in word problems. So it is something that I struggle with, to be honest. Like one of the toughest lessons that I learned is just like word problems were so difficult for me to understand. Like I'm kind of gonna understand it, but like building up the formula and like, you know, knowing what to use is just like a little bit hard for me. Maybe I'm about to practice it farther and farther. Yeah, so yeah.
Better. Super fun. I don't know if that's your thing. I sometimes enjoy word problems, sometimes I don't, because it takes just a lot more thought. That's okay. I'm going to teach you how to think about these. So in this approach to problem solving, we'll start pretty basic, and then I'll do the next few videos kind of progressing how to deal with some different word problems. Here's some general outlines on how you would go about.
Yeah, this is what is hard for me, like making the equation. And setting up the equation. That's like what is hard for me, to be honest. But like I think there is nothing hard. It all needs like some more and more of practice, you know, then I can nail it.
About solving word problems. Number one, the steps on this. Now, let me say first, before we get going, there's no possible way that I can teach you how to do every single word problem out there. There's an infinite number of them. You can make word problems up for everything. So I can't teach you how to do all of them. What I can do is give you 5 steps that help you think about this. It gives you just this pattern of solving word problems. Number one, the first thing that you should be doing here is reading the problem carefully. And what I mean by that is literally just read it. Try to get an idea about what's going on, but do not try to make an equation here. That's a wrong thing to do, because when you start assigning variables and try to jump into it too fast, we're going to miss some key points, or we're going to put things out of order. That's the problem. So number one, we're going to read it carefully. Number two, if you can, this is not always the case, but if you can, draw a picture or find a formula if that's applicable. So we're dealing with like area of a triangle or something, or we're dealing with square footage. That's a formula idea. We can deal with that. Or if we have like a height problem or a distance problem, you might be wanting to draw a picture. Stuff like I have on the board behind me, we'll get to in a minute. This is not a picture idea. So it depends on the problem, but read carefully for sure. Secondly, if you can, draw a picture or find a formula. Number three, after you've done that, this is for sure all the time, make what's called a verbal model. What a verbal model does, it puts your word problem into math type words. So this kind of organization of your thoughts. This is the biggest part. Most people skip making a verbal model and they try to go right to equations, and that's where most of the mistakes happen here. So verbal model, a big deal. We're going to discuss how to do that in the next few examples. Your word problem into math type words. So this kind of organization of your thoughts. This is the biggest part.
Like, what does he mean putting the word problems into math type word? Is that what he said?
Into math type words. So this
What does that
kind
mean?
of organization of your thoughts. This is the biggest part. Most people skip making.
Is it just like if it was like if they telling you like 4 is the difference of 2, that means that changing that difference into a math word which is going to be minus, or like if they are talking about something blah blah, then they mention is the product of these 2 numbers, that means that product will be changed into multiplication. Maybe that's how it is. I don't know, but like we will see. He will give some examples to us
in a verbal model, and they try to go right to equations, and that's where most of the mistakes happen here. So verbal model, a big deal. We're going to discuss how to do that in the next few videos. Sorry. After that, after you've made your verbal model, assign one variable. Now, when we get to systems of equations, I'm going to show you how to do this with more than one variable. That's pretty cool because it makes things easier. When you're able to use more than one variable and you know about systems, this becomes easier. For right now, we have to base all of our information on one variable. Never assign more than one variable when we're talking about linear equations in one variable. Lastly, yeah, you're going to solve it. As soon as you've done this, you'll have something at this point you can solve, which is kind of cool because right now what I'm telling you is that you really have all the tools to solve any linear equation like ever. You know how to deal with fractions, decimals, distribution, combined like terms, so you know how to do that. But that part, interpret it. In word problems, we never leave something like x equals 7 because that doesn't tell anybody anything.
Yeah.
Word problems are supposed to be applicable, or at least they came.
Yeah, like you wanna put your solution into words again, right?
From something that was applicable to somebody somewhere. So we're going to want to interpret it. So x equals 7 becomes it would take 7 minutes to do this job, or you could go 7 miles an hour, or it would be $7, something that's relevant to the word problem. So that's what we're going to strive to do in the next few videos. Right now, I want to show you how to deal with a few common ones. A lot of teachers are going to give this to you as like an introduction to word problems. This right here, we're going to read this carefully, but this is kind of a watered down word problem. That's okay. It's to get our feet wet on it. So let's read it carefully. A number divided by 5 equals a number decreased by 24. My goal in this video is not to solve problems here. My goal is to get us to the point where you can solve the problem. So get us basically to there, assigning the variable, making sure that we understand the concept of linear equation, and then you go ahead and solve it. So we'll read it carefully. Read it at least 2 times. A number divided by 5. Right now we're getting some math in our head. We're seeing what operations are there. We're looking for a number that means equals. Sometimes it just shouts at you. That's cool. Equals the number decreased by 24. No problem. So we're getting these things in our head, but we're not writing anything down yet. Number 2, drawing a picture. That's not really relevant. We're not going to draw pictures of numbers here. That we're going to write numbers, but not really a picture that would make sense. And there's no formula. Number 3, step 3. Well, the verbal model, that's actually what we've been given here. So this is a verbal model already. So we kind of skipped a few steps. This is given to us at step 3. So make a verbal model, we got it. Here's the idea. When we assign one variable, we're going to go through on these problems that are basically verbal models already. It's good practice to make a verbal model into an equation. That's why these are given to you by most teachers. Go through and read it really carefully. And every place where you see an operation, I want you to underline it and put the operation. Where you see the one thing that means equals, underline that and put the equals right below it. You see, when we understand how these problems work, anything that's written after the word that means equals goes on the right-hand side of your equation, and anything that's written before the word that means equals goes on the left-hand side. So,
Wow.
So let's start with that. So let's read through real carefully. A number, well, what's a number mean? So a number, we go, what number is it? I don't know. That's what gives us a variable. So when you read a number, that means a variable. When you read the number, that's referring back to the variable you've picked. It doesn't matter what variable you pick. Most people pick x's and y's because we're used to it. So we're going to read this and just say, okay, a number. Underline it. That typically means x, y, or whatever you want.
Yeah.
Divided by 5. Well, let's underline that. Divided by, well, that's straight up like a division problem. I mean, we know that. So let's put divide. We got that. The key one here, the word that means equals is crucial for you to find. A lot of times it's words like equals, is, was, represents, represented by. A lot of those different words are these word clues that tell you what's going on in the problem. Here for us, we have just equals. Very straightforward in this problem. So a number, we got x. Divided by, we got divide. Equals, now this tells you something. All of this is going to be one expression, and this is going to be on the left-hand side of your equal sign. This stuff goes here. The stuff after the word that means equals, sometimes is, sometimes was. This stuff is going to go on the right-hand side. So let's diagnose that real quick. So the number, whenever it says the number, it's got to refer back to the variable that you've already picked. So we're going to underline that, and we've already chosen x. So let's keep the same x. Decreased by, that's another operation.
It's just like minus basically. It is subtraction.
And if you're not familiar with these words, again, we had them in pre-algebra. We're just kind of going through the same thing, a little bit more advanced here. Decreased by, subtraction, minus, all those things mean subtraction concept. So subtracted from, decreased by, less than. All these things are subtraction concepts. So decreased by means subtraction. Now, if there's anything that I can stress to you, it's this, right here. All operations are written in order, unless they have one of two words. The word from, or the word than.
Oh, wait.
This, right here. All operations are written in order, unless they have one of two words. The word from, or the word than. If you see those two words, it reverses the order. This is why a lot of people get word problems wrong. They're written like this. Because if you read from or than, it's not the number minus, it's minus the number. From or than reverses the order of operations. If you don't see those, like our example, a number divided by 5 equals the number decreased by 24. We don't have the word from. We don't have the word than. That's great. Because what that means is that you can literally just write out everything in your word problem and it's in order. So we underline these things to go, okay, a number. What's the number? Well, your words you already picked. So we're going to underline that. All operations are written in order, unless they have one of two words. The word from, or the word than. If you see those two words, the word from, or the word than. If you see those two words.
Wait up. I want to know what does he mean by like all of the operations are written in order, written by like in order. So
two words. The word from, written in order. It's this, right here. All operations are written in order.
Okay, are written in order. Okay. So what does he mean like basically in order? Does he mean like using the Bermas rule? Is that how it is? Hey, hope this helps. Does he mean by all of the operations are written in order? Okay, so in this case, when they say like a number divided by 5 equals the number decreased by 24, you cannot do like the number decreased by 24 first. You cannot do it because so you have to do it in order, right? The operation must be done in order. So okay. It helps avoid mistakes like mixing up the order of operations. Okay.
Unless they have one of two words. The word from, or the word than. If you see those two words, it reverses the order. This is why a lot of people get word problems wrong. They're written like this. Because if you read from or than, it's not the number minus, it's minus the number. From or than reverses the order of operations.
Okay. So in this case, a number divided by 5, if it would be from a number divided by 5, like that means like it would flip, because like the divided by be like the 5 and the number by would be the dividend. It's how this is like you're gonna flip the operation, right? On the other way, maybe. Okay. There is from, and then okay, yeah, this is how it is basically.
Operations. If you don't see those,
got it,
like our
man.
example, a number divided by 5 equals a number decreased by 24. We don't have the word from. We don't have the word then. That's great, because what that means is that you can literally just write out everything in your word problem and it's in order. So we underline these things to go, okay, and number. What's the number? Well, x. Divided by 5, you can put divided by 5, but I would prefer if you put the fraction. So written in order. A number divided by 5, literally in order, equals the number decreased by 24 minus 24. That's a whole lot easier to solve than that is. Yeah, you know what? It is a linear equation. Yes, it does have a fraction in it. The first thing you would be doing, hopefully, since you watched the last video, change everything into a fraction. Find the LCD. Do you know what it is right now? Can you see that the LCD is 5? We went include these as our numerators. You'd have denominators of 1, 1, and 5. Your LCD is 5. How many places would you multiply the LCD? Well, how many terms do you have? Multiply 5 here, here, and here. These don't cancel, simplify, whatever. This one does. You'd end with x. You'd end with 5.
Yep.
Hopefully, since you watched the last video, change everything into a fraction. Find the LCD. Do you know what it is right now? Can you see that the LCD is 5? We want to include these because those are our numerators. You'd have denominators of 1, 1, and 5. Your LCD is 5. How many places would you multiply the LCD? Well, how many terms do you have? Multiply 5 here, here, and here. These don't cancel, simplify, whatever. This one does. You'd end with x. You'd end with 5x, and you end with 5, whatever 24 is. And then you'd have something that's very, very easy to solve. Try that on your own. If you're struggling with the fraction idea, watch the last video. I explained how you get rid of fractions in equations. That's not the purpose of this video. This video is how to get from here to here. Your job now is solving that thing. So this is the changing of a verbal model into equations. Let's try the next one. See.
So first I need to get rid of the 5. So I'm gonna multiply by 5, right? That's symbolized there. And it will be this, right? And then this will be also 5x, and it's how it is. I guess,
You can underline.
to get rid of like 5 in here and to get like and to isolate, I guess you need to multiply by 5, so 5 and 5 will cancel.
And start thinking about it as I'm talking through it. Some of these words that mean
Also,
math.
you're gonna multiply the 5 on the right side of the equation.
This down. Start underlining right now. So let's read it carefully 2 times. 5 times the number. Some things are popping in my head right now. Is 24 more than twice the number? Okay, let's read it. 5 times. I know what that means. A number. I'm getting that is. What's is?
So let me find the number basically. I guess eligible. Okay. So I guess squared by 5 equal to I guess minus 24. So they will all have Okay, it's just like look for an LCM for it. That's what it is basically. So it's 5. So what you can do is say it is 5, I guess. But this will be something like this right up. So instead of this, you also can say this. Alright, multiply by 5, and this one will cancel. Next, with this. So gonna multiply 5 by minus 24. So it will be 5, I guess, or 5 times 24. I don't know what it is. Long ass math, I think. 24 times 5, 120. 120. 120 minus 120. Okay. When I get rid of this one too, so I'm gonna subtract 5 from both sides. 5, I guess 5, I guess. Why? Then it will be, well, it will be minus 4x is equal to minus 120. So minus 4 and minus 4 on both sides. Okay, so this one will cancel. So divided by 4, what it is it like 40, right? I don't know, let me check. 30. So it's equal to 30. Okay, so the number is, I'm gonna do this interpretation. So I'm gonna say a number divided by 5 equal is the number decreased by 24. Then I'm gonna say like the number is what the heck, the number is 30. Is that what I'm gonna say? Okay, so let me say divided by 5 equals the number decreased by 24. Didn't do like step 1. So the number is 30. So all you need to say is just like how to interpret in here. So how to one of the steps.
Is one of those words that means equals. That's the key word here. There's never going to be more than one word in an equation that means
interpret. Okay, when you see the math like a number divided by 5 equals the number decreased by 24, here is how to interpret it. I didn't find out the number unknown. Okay, a number divided by 5. Okay, this is like, so the number. Okay, so interpret is just like doing it step by step.
model into equations. Let's try the next one. See if you can underline, start thinking about it as I'm talking through it, some of these words that mean math. If you've written this down, start underlining right now. So let's read it carefully 2 times. 5 times a number, some things are popping in my head right now, is 24 more than twice the number. Changing of a verbal model into equations. Let's try the next one. See if you can underline, start thinking about it as I'm talking through it, some of these words that mean math. If you've written this down, start underlining right now. So let's read it carefully 2 times. 5 times a number, some things are popping in my head right now, is 24 more than twice the number. Okay, let's read it 5 times. I know what that means. A number, I'm getting that is. What's is mean? Is one of those words that means equals. That's the key word here. There's never going to be more than one word in an equation that means equals because there can only be math into equations. Let's try the next one. See if you can underline, start thinking about it as I'm talking through it, some of these words that mean math. If you've written this down, start underlining right now. So let's read it carefully 2 times. 5 times a number, some things are popping in my head right now, is 24 more than.
More than. Twice the number. This is more than twice the number. What it will be is just 5 times a number will be x when I make this little bit, when I make it even thinner. So yeah, I cannot make it, but let's take the number as x is more than 5 times a number is more than twice the number. So if you see then, you gonna do it in the opposite way, not in order. So 24 more than twice the number, 24 more than twice the number. Like, I cannot change this into mathematical. So more, if you see more than twice, that means it's just like so 5 times a number is more than twice the number. This is just like 5 times x is, that means means equal. Okay, 24 more than twice the number. I don't know how to put this in to mathematical word, like 24 more than twice the number. So what is twice the number basically? It's twice the number multiplied by 2. Is that how it is, or just like square? I think it is multiplied by 2. Math. It's like multiplying that number by 2. Okay, yes, that's okay. I'm right then. Okay, so 24 more than twice by the number. Okay, what is more than 2? Like, more than stands for something. Okay, so it is greater than? Oh my gosh.
Twice the number. Okay, let's read it 5 times. I know what that means. A number, I'm getting that is. What's is mean?
So in here, I'm only gonna, I don't know this if it is equal to or like this, but yeah, is 24 more than twice the number. So it is x time is 2 x times 2 is 20. Okay, a number, okay, 5 times a number is 24 more than twice the number. Oh my gosh, this part to go me, like literally this part to go me. I don't know what I'm gonna do with this part. It's 24. Okay, let me just see.
Is one of those words that means equals. That's the key word here. There's never going to be more than one word in an equation that means equals, because there can only be one equals in a math equation, in a linear equation. So 5 times a number is, that's big. 24 more than, oh, right now in my head I'm seeing one of those words that reverses order. So I'm keeping that in my head. This is what reading carefully means. You're getting this stuff in your head, not doing anything with it yet, but you're getting in your head. I know what times means. I know what a number means. I know what is means. More than, okay, that than, that's going to reverse some stuff. Twice the number, that's a multiplication concept of 2 times. So we're getting the stuff in our head, and now time to start underlining. So let's go from left to right. 5 times. I know the times means multiplication. Probably not an x, because that looks a lot like a variable. Let's put a dot, because we know that means multiplication. 5 times a number. Okay, I know what a number is. A number is going to be a variable. Is, that's the big one. Is means equals. So I know that all this stuff is going to the left of my equal sign, and whatever this is, it's going to go on the right-hand side of my equal sign. That's it. 24 more, now more than. More than is.
That is calling me. So let's continue.
Is the concept of addition, but it has one of those words in it that flips the script, that flips the order. That's a
Okay, so more than, if you see more than, that means it is plus. Okay.
big deal, because this is where students get really confused. So when you get the word from or than in your word problem, instead of writing just plus, I don't want you to write just.
Oh, wait up. If I go back to my schedule, so that means it will be like 24 more than twice the number. So like I'm gonna say x times 2 plus 24. Is this how it will be?
Just plus. I want you to write plus 24, because when I say flips the order, what I mean is this more than this. It's not 24 plus, it's plus 24, and it's going to come after the next thing that this references. So 24 more than says, okay, take the next thing, whatever it is, and add 24 to it. So for instance, if I say, I have $5 more than you, you have to take your money first and then add my $5 to it, don't you? You got to know what's happened, what I'm referring to. The words from or than are reference words that refer to the next thing. So 24 more than whatever comes next says you're going to add 24 after whatever comes next. Now you're thinking, who cares? Freaking addition. It's commutative. Yeah, I get it. But wait a second. If If it's subtraction, it's not commutative. If it's division, it's not commutative. So we have to know that the words from or than, we're going to practice it now, that those words from or than are reversing words. They're reference words to the next thing, so that we don't make mistakes on stuff that isn't commutative. That's why we practice it now. So 24 more than, it's plus, yes, but it's plus 24, not 24 plus. This is the biggest mistake that happens on these type of problems. Okay, after that, twice. When you have twice something, like twice 50 would be 100, twice 1,000 would be 2,000. It's a multiplication concept by the number 2. So when we underline twice, we have 2 times the number that we've already picked. So let's look at one more time. We're going to keep some things in our mind, like from or than, and then we're going to just go left to right. Every one of these operations is written in order. It's all in order, unless you have from or than. We've already talked about it. So let's write the number let's write the equals down. Let's write 5 times a number. There's no from, there's no than. 5 times a number. You literally just write this. 5 times y. Done. You're good. The left-hand side of your equation, that expression is done. On the right-hand side, 24 more than goes, all right, yeah, we're going to add. We're going to add 24, but it's referring to the next thing. So I'm going to add 24 to whatever this is. 24 more than what? Well, more than 2y. More than twice the number. More than 2 times y. So we have our 2y. No problem. And then this says, take whatever this is and add 24 to it. Notice how the more than, that word than, puts it at the
let's find out what that number is. So 5x is equal to 2x plus 24. So let's isolate x. Okay, now first we're gonna subtract 2 from each side. Like 2x. So it will end up 3x equal to 24. Let's find out the number. 24. Okay. 3. Is this 8? Yeah. It will be x equal to 8. So we got x basically. So let's plug it in. So what we're gonna say is 5 times 8 equals to 2 times let me 2 times 8 plus 24. So 5 times 8 is 40. So basically the number is 40. Nope. Okay, 40. 2 times 8 is 16 plus 24 is equal to what? 24. Okay. So 40. Okay. So this has to be true, right? It will be 30, 40. So yeah. So that number is 8. That number is 8. Okay, amazing.
At the end of your equation. Puts it at the end of whatever comes next. That's it. That's your linear equation. Looks a whole lot easier, right? I mean, you could combine like terms, no. Distribute, no. Simplify, no. Fractions, no. Get rid of the smaller variable, yes. You get 3y, and then just divide by 3. It should be 8. Try it on your own. The last one. So 2 less.
So, yeah. It was day 12, and it is a Friday day. So I need to study online like an hour, but it looks like I studied more than an hour. I don't know. I'll see. So yeah, it was day 12. Studied math in every day, and yeah, it was another beautiful day, and I enjoyed it. So for that, see ya before we go and meet tomorrow. So yeah.